Assalamu alaikum. I'm Professor Dr. Ahmad Hussain AlBayati. I would like to thank all the conference's staff, and I'm grateful for taking part in the conference. I'm introducing the paper titled Enhancing Hyperparameters for Solar Energy Forecasting in Kirkuk, Iraq, Grid and Cuckoo Search Techniques. The paper is a result of around 1 year of research with my MSc student Azheen Hussain to improve the forecasting of solar energy in Kirkuk. The outline of the presentation is that first, motivation, methodology overview, data description and study area, hyperparameter tuning methods, research objectives, results overview, comparison between SVR and RF algorithms after hyperparameter tuning. Finally, the conclusion. The motivation of this study is that solar energy offers clean, reliable, and economically beneficial power. Photovoltaic and concentrated solar technologies play a role in reducing emissions and strength energy security. Secondly, Iraq, with its abundant sunlight and growing electricity demand, holds significant potential for solar adoption. Kirkuk is an important city in Iraq, which has the biggest Iraqi oil fields. It also hosts one of the Iraqi's largest gas power station, Mullah Abdullah Power Station. The hyperparameter optimization plays an important role in improving the accuracy of solar forecasting in Kirkuk. Finally, seasonal analysis further revealed a reliable forecasting across the year as shown in the results. Methodology overview. First, data source. NASA power datasets from 1984 to 2022 for Kirkuk is used. The dataset includes GHI, temperature, humidity, wind speed, and related variables. Secondly, pre-processing. Cyclic encoding for periodic variables, month, day, and also minimum maximum normalization for model stability. We use them in this paper. Forecasting models used. The forecasting models used includes support, vector regression, SVR, and random forest. We use two algorithms in this paper to see how they affected by the hyperparameter optimization, which are grid search and Cuckoo search. The model evaluation and validation includes time series split for validation. We use time series here in this paper also. For evaluation, we use three criteria: R-square, RMSE, and MAE. For further data description and study area, we can say the study area is located in the Mullah Abdullah region, southwest Kirkuk, high power potential with semi-arid climate, one of the Iraqi's largest energy production regions, ideal for solar forecasting research. The Mullah Abdullah region is an important area in Kirkuk, and Kirkuk is an important city of Iraq. Data source, NASA power database used. since 1984 to 2022. The dataset provides long-term reliable and solar variables. The key variables used global horizontal radiance, GHI, temperature, relative humidity, wind speed, clearance index, DNI also used. For pre-processing, cyclic encoding of month, season, minimum, maximum normalizations, and missing data handling also used. The study area located in the Mullah Abdullah region, southwest Kirkuk, solar potential with semi-armed climate, one of the Iraqi's largest energy production. The region is, we can say, ideal for solar forecasting research, especially in Iraq. The data source depends on NASA Power database from 1984 to 2022. It provides long-term reliable and solar variables. Key variables, the used key variables are global horizontal, GHI, temperature, relative humidity, wind speed, and clearance index, DNI. The pre-processing used, as we mentioned before, cyclic encoding, season, month, day, minimum, maximum normalization, and missing data handling. Hyperparameter tuning methods. We have two methods, Cuckoo search and grid search. In Cuckoo search, we can say meta-heuristic optimization inspired by natural cuckoo behavior, efficient in exploring wide parameter spaces, helps avoid local minima and discover near optimal configurations. In grid search, we can say exhaustive evaluation of all predefined parameter combinations. It ensures systematic coverage of the search space. It produces stable, reproducible tuning outcomes. Research objectives. We can say the objectives are first, apply support vector regression and random forest for monthly GHI forecasting, improve model performance, use grid search and Cuckoo search. We can say the other object B, analyze the effect of optimization on accuracy, example, improved R-square, reduce RMSE. Evaluating NASA Power dataset for long-term forecasting suitability, identify the most reliable forecasting model for solar energy planning in Kirkuk. We have two objects, object A and object B. Results overview. Model performance summary. We can say two models evaluated, support vector regression and random forest. Results demonstrate that hyperparameter optimization significantly enhances forecasting accuracy for both models. Both of them they are enhanced by tuning parameters. Time series cross validation revealed the strong seasonal effects. showing models perform best in stable summer months and weakest during variable winter period. It's better in summer. SVR results. SVR baseline performance improved dramatically with tuning. Best optimized accuracy achieved using grid search, yielding R square 0.9789. Also improved RMSE and MAE compared to default SVR. Cuckoo search also improved the SVR performance, but slightly less than grid search. Therefore, grid search is better for SVR in this forecasting, solar forecasting in Kirkuk. In random forest models, we can say RF showed stable performance across all configurations, consistently produced reliable prediction, even without heavy optimization. Optimization improved accuracy, but with smaller gains compared to SVR. Therefore, SVR affected more by optimization, and especially with the grid. Especially with the grid search. The comparison between SVR and RF after hyperparameter tuning. Firstly, we see RF performance, especially as we see in the table. RF, default RF, R square for default RF is 9.9723, RMS is 0.3185, 0.2397. We can say it's good performance without tuning. But with tuning, Cuckoo search tuning, if we apply Cuckoo search tuning with RF, we can see the R square is 0.9725. It's better, but it's not too much enhanced. RMSE is 0.317, is also decreased. MA also is better. RF is less sensitive, we can see, to hyperparameter search. With the grid search, RF with the grid search, we can see R square is 0.9725, like with the Cuckoo search. 0.317 is also close to RMSE with Cuckoo search. We can see is with MAE for RF. With the grid search is 0.2401. RF is less sensitive to hyperparameter search, but also there are some optimization, and the best we can see is also better if we use it. For SVR performance, we can see SVR, default SVR is R square is 0.9590. RMSE is 0.377, 0.2809 for MAE. With the Cuckoo search, is 0.9757 is better than default. RMSE is 0.2941 is also much better from default. 0.2315 for MAE is also better. We can see that has been enhancing is more. With SVR with the grid search is 0.789, RMSE is 0.270, and MAE for SVR with the grid search is 0.2096. We can see its best performing configuration. I think is according to paper, SVR plus grid search is the best result of optimizing, use, and enhancing. in this paper. As we see in this chart, the SVR and RF after hyperparameter tuning, we can see in the baseline, both of them without tuning. For SVR is 0.959, for RF is 0.972. But with Cuckoo search, for R square is 0.976. RF is 0.973. Cuckoo search, grid search for SVR with the grid search is 0.979. For RF is 0.973. Here we can see with R squared for baseline, SVR is less than RF, but with tuning we can see SVR enhanced to be better than RF. In this slide we can see the effect of tuning. According to RMSE value, we can see baseline, that's mean the default value is 0.378, but for RF is 0.319. When we use Cuckoo search, is the RMSE value for SVR dropped to be 0.294, while RF is, we can say, moved to be 0.317. It's not too much less than default values. And with grid search, RMSE value for RF the same for grid and Cuckoo search, but less than default. But with the grid search, RMSE value with SVR is 0.270. Is, we can see if we compare the value with Cuckoo search, with grid search is less than, and we can see the big difference. We can see also we have the big also is better than default value for SVR. Therefore, if grid search affected by grid search too much, and is best if we compare to all the situations as shown in this chart. If also we compared according to MAE, we can see its baseline for SVR baseline, that is default values without tuning, is 0.261, but here is 0.24. SVR with Cuckoo search less than, enhanced to be less than RF. Even RF is according, we can say same. And also with the grid search, SVR is affected more by grid search. Then, therefore, SVR enhanced with both Cuckoo search and grid search, and it is affected more than RF. In this slide, we can see the comparison between SVR and RF after hyperparameter tuning, but here the performance depends on the seasons. R squared for RF and SVR as shown in this chart. We can see the highest accuracy in spring and lowest in winter, confirming strong seasonal effects on GHI forecasting performance. The conclusion of this presentation is that shows the machine learning models can accurately predict monthly GHI for the Mullah Abdullah region in Kirkuk using Cuckoo search and grid search is significantly improved model performance. SVR achieved the highest accuracy after optimization, where R square equal 0.9789. While RF remained constantly stable, time series split ensured leakage-free validation and more elastic performance assessment. These findings confirm the importance of proper tuning and temporal validation in building reliable solar forecasting system. I wish to express my sincere gratitude to everyone involved in the conference, including the participants and the audience, for their attentive engagement. Thank you very much. Wassalamu alaikum wa rahmatullahi wa barakatuh.